Hello, everyone, and thanks for joining today's Masterclass Series Part 1, ModelOps, MLOps, and Managing Model Risk.
Okay, excellent. Yeah, thank you everyone for attending today. This is the first in a whole series of classes where we're really going to dive deep on this particular topic and how our solution can help you with these specific problems. But what we want to do first is we're actually going to, let me bring up there we go. We're actually going to today really understand the space. There's a lot of confusion out there between what's model ops, what's ML ops, manage model risk. What does it mean to my business? What does it mean, to me personally on that kind of things on that. So today's presentation will be all slideware this time around, but I promise you the next three, we will actually be doing very few slides and almost all hands-on with how you actually build and solve these problems for your company using our solution, where we're going to show you this stuff running live, and we're going to dive deep into each item so you really understand it. But this time around, we really need to have a consistent language we can all speak when we're talking about these different things. So this first one will cover that, and we'll get the background information in. So then next time, what we can actually do is look at some of these individual topics in a deep dive fashion, in specific around the model risk management practice and how you need to ensure all these different phases. And then we're going to dive into each of those phases, and we're going to explain those phases today. But then we're going to look at, next time we'll be looking at how do we make sure the models have the quality and are actually even risk accessible and monitorable and all these other things. How do we make sure that happens within our organization? And we'll be showing you how our solution enables that. And then actually, when your models are ready to actually go out to production, what kinds of things need to be done? How can we ensure that? How can we ensure the quality? Again, even more like security risk and things like that. And again, we'll be doing live demonstrations of that as well. And then the final one on October 28th, we'll actually be looking at, okay, once it's out in production, how do we actually monitor it and eventually retire the model? Models have a shelf life. And how do we ensure that? And what needs to go on there? And how can our solution, again, help to do that so that you don't have models that have been out there for 2 years and nobody even knows they exist. There's no owner anymore. Seen it happen, and then something goes wrong, and that's not fun. So we're going to be next three sessions will be all hands on. This one's going to be more slideware based on that kind of thing. So as we get into it here, we're going to actually examine a little bit of some background information on definitions, because we see tons of confusion in the space here with what is MLOps, what is ModelOps, why are they different, etc. So I want to make sure we're all up there speaking the same language so we understand, because we've seen so much confusion in this space. And really, MLOps is targeted very specifically at how do we actually create a software development lifecycle for models, for very specifically machine learning models. There's unique requirements around machine learning, especially the idea of retraining, shelf lives, and et cetera, that do not apply to its traditional code. So they had to kind of extend the DevOps definition of what, how do we actually deal with these things on that kind of things, and how do we make sure these retrainings occur? When do we know to do retrainings, et cetera, on that kind of thing? So it's really the idea of creating that complete development loop of everything from basically, where do I get the data? How do I prep the data? How do I pull it in? How do I train? And then how do I get feedback about how it's doing and start this whole cycle over again? So it's a purely practical solution targeted at what we refer to as this kind of development lifecycle for machine learning models. So when we actually do that, it's really heavily biased towards kind of the front end, because it's targeted heavily at data scientists and how they help them to actually train their models, get their models in place, and all of this kinds of things. So, what you'll see with MLOps solution is they're very low level, lots of experimentation, lots of tuning, lots of things like that, which is a very important process. And then it also provides a lot around the monitoring of these models once they're out there, because again, machine learning models, as we well know, do actually tend to degrade over time. So we need to capture information about warning signs that perhaps this model needs to be retrained, retired, on that kind of things on that. And then to do that, they kind of capture some very basic information about the model. There's not a lot of details about the lineage. You'll see more around the development process, the experimentation process, things like hyperparameters that were used for the actual tuning of the model. So, they have a little bit idea of what we refer to as a model catalog or a model inventory. But, they're typically very much kind of key off the experimentation phase and things like that of where they get that. And then they typically have some simple form of deployment that's monitorable to actually allow these machine learning models, again, machine learning models only, to actually do inferences behind something such as REST on that kind of things, and typically have some kind of a batch mode as well and manage that. Now, when we actually talk about ModelOps, it's much, much, much more. It's really, again, looking at the model in your entire business flow, everything from the idea of doing a model, so model ideation, all the way actually out to how do we move it through the business? How do we ensure this model's complete? How do we know this thing's going to be monitorable? There's a lot of steps that have to go on there. And by the way, your machine learning experimentation is part of that phase, but it's just one part of it. And in fact, we very much view that, the reality is, yes, we all love to talk about artificial intelligence models and machine learning models and things like that because, they're the newer technology that people are utilizing. But let's get real. In all of our businesses, we know there's even simple decision tables. There's Excel spreadsheets making business predictions that actually have to be kept track of. There's if-then-else statements. There's all kinds of things. Traditional logistics regressions. These are not going away. They are in our business, and they do pose risk to our business if we don't put some process in place to make sure they're there. So a ModelOps solution takes the model all the way from even just the idea of a model, like if it's out there and we haven't seen it, all the way through to how do we get it built, how do we ensure its quality, how do we ensure it's complete, et cetera. And we'll be examining that in detail shortly. So when we see these solutions that provide a ModelOps as opposed to MLOps, there's a lot more behind them. We really start with the idea of an orchestration of how do we move it through the business? How do we make these different participants who are not only developing the model, but have to ensure the quality of the model, have to actually look at the overall security risk, look at the business risk, model promotion, all these different kinds of things. There's a whole series of stuff that actually has to happen in the business. So these solutions actually do that basically full orchestration across that. And we'll talk about that more in the next slide where we talk about model life cycles in specific. But I do want to talk about some of the other features that differentiate ModelOps solutions from a MLOps solution. It's first of all, it's also going to typically when you see an MLOps solution, it's kind of you tend to buy into the solution. So things like Kubeflow or things like that, where you're kind of locked into that solution and that. When we start to talk about models across the business, there are n number of those. So you're going to have R code, you're going to have SaaS code, you're going to have Python code, you're going to have the machine learning code, you're going to have things from things like Kubeflow, you're going to have things like SageMaker models, you're going to have there's a multiplicity of them out there, and they all need to be managed for risk. You can't ignore those. So it needs to work with large amounts of different development environments and have a consistent look and feel and consistent metadata across those and manage that. And you'll see the ModelOps Center solution when we get hands-on with it does a great abstraction of that, where you'll see all these different models come from all different sources in one place, and we'll manage them consistently. It's also going to need to leverage existing IT infrastructure to deliver it, things like Jira and ServiceNow, and et cetera. The data scientists may want to use something like built-in Kubeflow with its feedback system, but probably realistically, if you're getting into IT or crossing business units or business lines or any of those kinds of things, you're going to need a centralized human task that tells somebody they need to do something. And a good solution like ours will interface with things like Jira and ServiceNow because they've already made investments in those in the business, and actually to drive those human tasks. And as throughout the course of the series, we'll be showing that. And it also needs to be realistic about it's going to go not only to a variety of different run times themselves, like a SageMaker versus a REST versus a Kafka versus a a Docker deployment versus maybe it's an edge case where it's actually getting deployed down onto a handheld device. These are all real world scenarios. So it needs to manage that multiplicity of how they get out there, the different technologies involved, different deployment methodologies, and not just assume you can do everything in REST, because you really can't. When you get to a full line business, if you're a manufacturer, you're probably deploying models right onto your manufacturing machines. You need to manage that. You don't want that going wrong on that kind of thing. That has real costs to the business. So we need to manage that kind of risk as well. And then when we get down to the reporting tools that are reporting across the business, and you want to share executive level reports and things like that, we're going to want to, again, utilize standard stuff you're already using now, not something proprietary. A CXO is not going to want to log into some system somewhere to view a report. They get a Tableau report, as an example. They're used to that, and we got to have those kinds of things. So really, the idea is the ModelOps solution becomes this conductor of the orchestra across all these different different investments you've already made, familiar technologies, things like SharePoint, et cetera, and things like that, to pull them all together and provide that consistent view across all of those items. So when we actually look at a ModelOps solution, and like an MLOps solution, a ModelOps solution is actually trying to answer a lot of high-level questions about, like, how are my models performing? Are they compliant, regulatory? How many do I have expiring? What's the return on investment of what I've done in these models? All of these kinds of things. So they're looking at business level questions. Yes, they're going to capture all that low level information as well, but the ultimate goal is to be able to answer these kinds of levels. So, this is a quote directly from Gartner on that kind of thing. Is the idea is that, we really do want to be that center repository of information that's looking at all of these items that we see, all these artifacts, all these models. Where are we? Where are we as a business? How do we make sure they scale? Are we getting our money out of them? All these different kinds of things. So to do that, for instance, there's the SR 11.7 guidelines. These are, a federal kind of report that is well accepted in highly regulated businesses like the banking industry and things like that, of where you must follow a flow to ensure that what's accepted is, I've done my due diligence. I've protected against risk the best I can, because we can only do so much, and that's all they expect. And then, we're seeing similar things with the EU and et cetera as well. So as models come out there, they're going to hold you accountable, but this is kind of the golden standard for, it's a big, long document. So this is kind of a summarization of the steps that we believe represent that process and allow you to ensure that. And we're going to walk through each one of these and how we represent those. So we actually will have a bit more detail here on that. To do that, what we do is we use something called the Model Lifecycle, and we'll be working with these a lot this week. Now, this one's an eye chart. Don't worry, we're not going to go into it on that kind of thing. To give you an idea, we use BPM notation to actually represent these model life cycles because they're dynamic. Regulations change, etc. You want to be able to upload this in your system, customize them to your business, and not have to wait for a code change. So we use BPM notation to do that. It's not just BPM notation. We have high-level things, drag and drop in, and we'll be doing that this week, where you can drag in something like, run this monitor on this model, and if something goes wrong, send me a JIRA, and you can put these together, and we have a whole big library of these already, and we'll be examining one in detail today, so you understand the notations and what we're doing, that breaks down that process we just looked at. So, it's not a data pipeline flow. It's not like Airflow or those kinds of things. It's business processes that will actually run over long periods of time. This could span 6 months. Let's get real in some businesses. Now, ideally, the goal of this is to reduce that time and make it quicker, so you're not bouncing back and forth between teams. But the ultimate goal is to actually drive and run that process. And this is how we integrate in existing IT infrastructure. So we can create a JIRA ticket, wait for it to get complete, then continue on when we know the ticket is complete and do the next step. We can work between lines of business, etc., by doing that. So, for example, and we're going to dive into this in detail again, it's in in the eye chart, where we're going to actually follow a simplified version of that diagram we just showed you, where we actually go through and ensure each one of those steps is complete. Because the end goal is our solution, ModelOps Center, will actually drive all of this through for you, but also more importantly, it will give you the path that it took and associate it with the model forever. So if that model is ever audited or in question, or you just want to know who did what when so you can find out something, we're going to have that exact path laid out for you. And we'll be seeing that over the course of the next three items, where you'll be able to see that everything was actually done, who did it, when, where, and it will fill out that path, because as you see, there's choices and branches that can be made based on the outcomes of the model, et cetera. And that forever will be associated with a version of a model. So anytime anybody comes back and wants to know anything about the model, just even who to contact about it, or worst case, you're ever audited, you'll be able to show you did the due diligence that was necessary to reduce your model risk. And that's what the regulators are typically looking for, both in the US and the EU, is that you tried your best, because none of us are ever going to be perfect, but we got to put at least enough process in to ensure that there's some quality within that model. So again, what we're going to do now is actually walk through how we are going to implement within each of the phases what needs to be done and what that looks like. In the next classes, we're going to go through each of those larger blocks, and we're going to dive into these in detail and show it to you live and what the features are there to actually do that. We have some really unique abilities for how we not only integrate with the systems, but handle boilerplate for documentation generation and stuff, so that your data scientists are wasting time filling out documentation and stuff and things like that. So the first block we're going to look at today to set the stage, and we'll be actually live running through this next time, is and this is what's unique and very different from MLOps and what things that we have ModelOps, is we want to actually start in SR 11.7 with just the idea of a model. What we need the use case definition, much like a story in the agile software development process. You want to just describe what is our goal. And as soon as you do that, we want to do that with a use case document written in Word or things like that, or whatever your favorite tool is, PDF, etc. And then we want to actually basically get somebody in the model risk classification area to actually look at not the implementation of the model, but what risk to the business is this particular model. If this thing is making credit decisions based for applicants, there's a lot of stuff. It's fairly high risk. We got to make sure it's equitable. We got to make sure it's fair. We got to make sure it's accurate. We got to make all of these things, because it really exposes us. Now, if it's generating an internal forecast report, it's probably a little bit less risk to the business. And maybe we can take a slightly different simplified path because of that. Or it doesn't need the full document, or it's a different document it needs because it's only being used in that things. Whereas the other one, I may have a federal document I have to fill out, and it's the exact one, and it's got to be there. And so, we want to gather the information before anybody even begins to build the model, so that we have that idea and the data scientist actually understands the task at hand, understands the scrutiny they're going to be put to, and understands, the potential risks to the business as to what they're doing. So it's important we get that kind of information up front. So, this phase here, you can see where it'll actually go, and we're going to then we're going to do this live next time. We're going to get a use case document, actually create a JIRA ticket with that use case document attached. So the person who does this risk assessment just does it all in JIRA. They don't leave JIRA. They don't come to another tool. It's all right there. They complete their ticket, and then they'll move on that kind of things. And then we're just basically going to go on and actually say, hey, developer, go out and actually now, here's your ticket, here's your use case document, here's the risk assessment we received. And again, they'll receive a JIRA ticket. We're going to use JIRA for these demos. A little simpler for us than ServiceNow, but we support ServiceNow, Xamid, some other ticketing systems as well. But we're actually going to go and create that development task ticket. And then in the next phase, what we're going to do is, we advance on to the next item. What we're going to do is actually say, go develop the model. Now, this is where a ModelOps solution kind of hands it off. You guys are as the data scientists, are developers out there. You're actually going and developing these models, and you're actually want to use X number of tools. You may want to try it in SageMaker. You want to try a TensorFlow version. You may want to try several different platforms, Azure ML, something else, to get several experimentations going to actually work to this use case. The idea being, that's where we step back we say, go use all the tools you want, figure out what's best, do your experiments, and get back to us with, 1, 2, 3, 4, 5 potential models that you believe are actually good for that as the data scientist. And then we will then pick up and validate those contenders. So we're very hands-off when it comes to the development process, but we make it easy to import those results into our system, and we'll be showing that as well and that kind of things. But then we're going to actually do some verification. One of the big things that is a challenge in model risk is making sure the information is there, like baseline data, training data, et cetera, on that. So we're going to be able to go through and actually say, hey, yeah, this model is complete. I have all the information necessary to actually do that model implementation. So, we have the training data, we have schema definitions, we have things like that. And then we're actually going to go on and then we're actually want to run some standardized tests on it that model risk management uses. So we provide that ability, and we'll show that in detail and how you can make your own tests even and incorporate them in the system. And then actually have a document template that automatically populates with those results. And we'll be showing that as well on that kind of things. And then, so again, we'll use Jira to capture that. So, and rather than model risk management trying to chase down all those assets, chase down test results, create their own plots, and et cetera, we'll do all that for you. And it'll actually happen, and you'll just get the notification, and we can go on from there. And then once we actually have those risk assessments or reviews occurred on that kind of things, we actually want to get to the productization of the model. We want to do things like security scans, Veracode, and we'll be showing how we can do that with Jenkins and actually pull that information together. Because again, you have existing investments there. We want to do a security scan of the Python code or whatever the implementation is to make sure we're not putting something out there that puts us at risk. And then finally, we actually kind of want to get a final clearinghouse review of, was everything done? Is this good? And then promote it into a staging environment where maybe it runs on all the data, some of the data, and again, the different deployment paradigms there. But again, this overall model lifecycle can handle long-running processes. It's not like a data flow item. So we can do things like you can see here, we'll actually wait a week. And then we will pause the item for a week and then go wake somebody up after a week with a ticket saying, hey, go take a look at that. Did it run okay? Are we good? Et cetera, and that kind of thing. So, we'll actually capture that kind of information, manage that promotion process before we actually get it out to production. But once it's out to production, then we actually want to not only monitor the model, we want to make sure something gets done if a data drift detection fails or that kind of thing. So we have a model lifecycle that gets run regularly and captures results about like things like stability analysis and things like that. And we'll show you, we have a whole bunch right out of the box you can just use, and you can create your own and add them into the system if you have something specific you need. But more importantly, when it goes wrong, we can do things like, for instance, we'll be showing how you can fill out a exception report right into a Word document populated with the exact issues and model tests that failed, and send them along as part of a Jira ticket to somebody to go look at. So, that's really powerful as opposed to just getting an alert somewhere and it's an email, somebody maybe does something. No, they're going to have the information at their fingertips, ready to go to actually do that. And we'll show you how to build those as well and that kind of things. And then all models have a shelf life. So, at the end of the day, we need to get this stuff, make sure another proposal's coming up and another item is ready to do it. So we're going to manage that process as well for the retirement of models. Then finally, we're also going to be looking at the concept of how do we look at the models holistically across the business, and we can use actual things like we have Tableau and Power BI integration to pull together all the information generically about all the different models in your business and the overall risk they're bringing to your company on that. And that's really important information, because the government's starting to crack down on these things. They're coming down. They've come out with some pretty strong statements about the Federal Trade Commission and the EU. You can read this yourself as well, but it's basically, hey, the end is, but keep in mind that if you don't hold yourself accountable, the FTC may do it for you. So these are guidelines and things that help prove that you're trying to hold yourself accountable and can help that, because I would rather be accountable for my own business than have somebody such as the EU or FTC actually come down on me later. So that's the goal of this whole series, is to show you how to build these processes for your business using a variety of different models, development platforms, et cetera. And we're going to do those hands-on over the course of the next 3 sessions to walk you through each of those and how you could incorporate that into your business to make sure you have the best practices to protect yourself against these kinds of situations. So with that, I'll try to get to a couple of these questions. Bear with me, I've been talking. So I've got to read them over real quickly here. I'll do that. A few specific business risks of not having oversight of all these different models, from Excel rules to base to ML. Well, I mean, that really gets down to the actual use case of the model. And, real world, what we've seen is they make bad predictions is the simplest one. So bad predictions, I mean, if let's say example is like a market cap kind of situation where we're predicting cash reserves or something for reselling loans or something, if that's off by, even 0.5%, that's a huge loss to the business and can really get you in trouble. But more importantly, we also talk about equity and other things as well. Exposing yourself to risk because your model has an unconscious bias. Just because the data doesn't contain that doesn't mean, as we know, that it can't maybe perhaps not be an equitable model. That's going to have risk from a different aspect. And there's all kinds of different ones that are out there, from real just ROI, kind of cost of the business, to then just potential exposure of items we may be doing that either directly politically, socially, et cetera, expose our business to a risk that we don't want to do, either consciously or unconsciously. So we need to protect against those kinds of things. So, we can see those within a variety of things. IAM permission managed, who is allowed to have access? Yeah, we do actually integrate with IAM and OAuth 2 in specific. IAM is tend to be more targeted at our SageMaker implementations and things like that, and our access to S3 and things like that. The overall model lifecycle itself is always just an administrator type access. As far as filtering like the past of what you've seen, for people can only see certain stages, that's not something we have done and seen as a request yet. It's definitely possible. It's just not something we particularly do that, but we typically use OAuth 2 and things such as Ping Federate and things like that for our security. We do not have the concept of users built into our system because we are an enterprise grade solution. So realistically, that's just not something we would do. We use your groups and identities and et cetera from OAuth 2. We feel that's a better approach from that. How does completeness of data play a role here? We don't store the data very specifically into our system. There's lots of solutions that do that, data warehouse solutions, et cetera. Instead, we store references to them. So that can either be through like a versioned S3 bucket, a repeatable data warehouse query, such as into something like Snowflake, which we support as well, where you give it a time boxed queue and your data warehouse supports that. There's a lot of different solutions. We choose to integrate with those solutions because they are their own problem space in its own, especially when you come to versioning data, repeatable data, et cetera there. So, we have patterns and suggestions of how to actually do that, and we will capture the reference to that. The idea being that we expect that reference to it to be a repeatable item and or versioned from the system that's providing it on that. So, the actual management and landing of the data, that is not something we consider part of model ops. That's data ops. And there's definitely a whole data engineering practice behind that. We used to do some of that, or I used to do some of that myself as well, and that kind of thing. So that's a whole nother topic, any of this says. Champion Challenger, yes, absolutely. We support that. We have that in our UI on that kind of things, and we can show that as well. And on the ethical fairness items, we use we actually will go into this more as to how we do monitoring, and it's something we call with a monitoring model or an associated model. So we use off-the-shelf items to do that, but we execute them. We can track the results. We can look at the results for outliers using decision tables and actually alert based on those results. We will be going through that in detail in a future in one of the future classes on the monitoring. I think off the top of my head, I think it's the second one. Not next one, but the third class overall, but the second hand-on class on that as well. And the ethical fair, again, we will go into details of that. We use things such as equitous bias and other algorithms on that. But we're built to take future algorithms as well, as the cool thing. And so we'll be specifically do that. And canary testing is absolutely, that's the idea. There's multiple ways of doing that, whether you're doing a subpartition within a K8s cluster, or where you're doing a partial processing of some of your results, or whether you're actually deploying into a parallel environment or things like that as well. So we do have some paradigms we can talk about there as well. So I think I got through all of those questions. I know we're just a minute or two here over, but I want to try to get through those, and we'll be exploring a lot of these in more detail as we do the next 3 classes as well, where we get hands-on. So with that, I want to say thank you for the time. Thank you for joining today. I really hope you join in the next 3, and I promise less slideware. That'll be 2 or 3 slides, and we'll jump right into the product and get hands-on in the next 3.